Cybernetics, SMC Society chapter of IEEE Delhi section, Communication Society of IEEE Delhi section, Consultants Network Affinity CNA Group of IEEE Delhi section, Life Member Affinity LMA Group of IEEE Delhi section, Inter-Society Relations IRF Standing Committee of IEEE Delhi section, Industry Relations and Special Interest Group on Humanitarian Technology, Site Standing Committee of IEEE Delhi section, with the Associations of Computer Society of India, Institute of Information Technology Professionals, IITP, ISTE Delhi section, and IETE Delhi Center as technical collaborator welcomes you all to the webinar today on cloud computing digital transformation. It is a moment of pride and honor to announce that we, with united hands, mark special contribution for the monumental occasion Azadi Ka Amrit Mahotsav, an initiative to celebrate 75 years of glorious independence by organizing thought-provoking sessions for a better future. Today's webinar is also an initiative for the celebration of Azadi Ka Amrit Mahotsav. According to statistics, the global cloud computing market is expected to reach $623.3 billion by 2023. According to Cloud Computing Growth Stats, the industry will grow at a compound annual growth rate CAGR of 18% during this forecast period. Cloud computing is rapidly penetrating in almost every walk of life and becoming pervasive and ubiquitous every coming day. The webinar today aims to discuss the various important aspects of the cloud, like technical and business perspective, key enablers, various service and deployment models, adoption challenges, typical cloud journey, architecting for and in the cloud, patterns, anti-patterns, and related case studies and roles and responsibilities of cloud architect, embracing cloud modernization and digital transformations. The webinar, with the help of use cases, will explore all these dimensions today. I would first take this opportunity to welcome amongst us our distinguished panelists for the day. We are privileged to have amongst us a galaxy of experts. I would first welcome amongst us Professor M.N. Huda Sir, Director, Bharati Vidyapeeth's Institute of Computer Applications and Management VVI CAM, and Vice Chairperson IEEE Delhi section to address the participants with his inspiring words.
Good evening, everyone. Dr. Ritika, am I audible?
Yes, sir.
Good evening, everyone. I take this opportunity at the outset to welcome first my valued speaker, Mr. Akash Sharma today, who, despite his all engagements, when I requested him, readily agreed and is here with all of us to share experience that how and in which way the digital transformation which is happening in technology domain with the help of the cloud can be explored or can be utilized by all of us. So welcome, Mr. Akash.
Thank you, sir.
I also take this opportunity to welcome all the participants and all the very elite group of experts like Mr. R.K. Singh, Mr. Dr. Subramanian Krishnamurthy, and many very, very senior experts amongst the audience at the level of the vice chancellors, deans of the universities. So I take this opportunity to welcome you all in this webinar series of IEEE, BBICAM, IET weekly even webinar series, which was started way back in the background of the COVID-19 in May 2020, and since then we are continuing. This is 111th edition of that particular webinar. So a century has already been crossed, and the next century is in pipeline. So thank you so much for joining this. All of you know that a major digital transformation have been brought on technology front using cloud computing. And cloud is such a model using which everyone who is utilizing infrastructure, utilizing services, utilizing platform need not to bother now. Now they need to only subscribe to some or other cloud wherever the services are, and rest are being done by the service provider of that particular cloud. It is as easy to understand as that if we wanted to have our own electricity generation system, probably will cost too much. Earlier, maybe around 100, 150 years ago, even in India, many Rajas, Maharajas used to do like that. But today, can you imagine that we will have our own grid? Not required at all. There are service providers like in Delhi we have a Tata Power, in Delhi we have a Reliance, or otherwise there are various government power supply divisions which keep on supplying powers. We have to only apply a connection. A meter is being installed in at our house, and we need to avail the services and pay as much we use. Not need to go behind the system that what and which kind of installations are required for this. Exactly in the same way, the cloud services are being made available in almost every technology domain, and we need not to bother about its investment. We need not to bother about its technical maintenance. We need not to bother it about its managerial aspect. We need to only bother to make payment on time, and that to pay as much you use. That is why this has been such a successful model. So we need not to own it, rather we have to subscribe it. So that is the fundamental basis of cloud computing model, and that is where from the virtualizations, the placement of servers, and placement of softwares, and placement of various services on some or other platforms are coming. With this background, we are starting and we are trying to understand in this deliberation, in today's deliberation, that how and in which way we can avail services, and to which way this digital transformation is going to touch each one of us. So I'm sure that the deliberations, that the discussion which will be happening today will certainly enrich us, that how and what the cloud computing enabled digital transformation can benefit us, and how in which way we can take advantage of it. Thank you so much, dear participants. There are many other technical lecture series as part of this webinar, which is announced till I think the second week of April. The slots are blocked, and the 4 more webinars are open for registrations. If you have not registered so far, please do register for that. The second, the way we started an initiative of having an international journal in the domain of information technology 15 years ago in 2009, exactly in the same way, we have again started another incubation of international journal of research in multidisciplinary studies. Dr. Ritika has already briefed you. If you have a survey paper, review paper, or original research paper, you wanted to start with your publications, you can always avail our services for submitting your research papers in that journal. The link and other details shall be shared again by Dr. Ritika. Thank you so much. Keep learning despite disruptions. Keep yourself busy in learning related activities. And that is the bottom line for which this webinar was started. Wish you all the best. Stay safe, stay healthy, stay vibrant, and keep attending our webinars. God bless you all. And I always say कि जैसे है कि अगले हफ्ते फिर कोई सीरीज आएगी, तो उसी तरीके से है कि फूलों की तरह फिर खिलेंगे हम, फूलों की तरह फिर खिलेंगे हम, और अगले सैटरडे एक नए टॉपिक के साथ फिर मिलेंगे हम. Wish you all the best. God bless you all. Thank you so much. Over to you, Dr. Ritika.
Thank you, sir. I would now welcome amongst us our expert speaker, Mr. Akash Sharma, Solution Architect, Digital Analytics Division, HCL Technologies.
Hi everyone. Can you hear me?
Just a minute, Akash. I would now welcome amongst us our expert speaker, Mr. Akash Sharma, Solution Architect, Digital and Analytics Division, HCL Technologies, with an e-bouquet. Mr. Akash carries over 17 years of experience specializing in cloud-native development, microservices, and application modernization. Presently working as a solution architect with HCL Digital's Analytics Division, he was the founding member of HCL Google Cloud COE practice. Recently, he has also architected cloud-based solutions for different domains such as finance, healthcare, and media. In his present role and past experiences, he has also had the opportunity to conceptualize and lead the in-house development of cloud-based products and accelerators. He carries multi-cloud experience and has been associated with startups and also involved in training and mentoring. A master's in computer application, he holds GCP and AWS Cloud Architect, Developer, and other industry certifications. So I welcome you today to this session, Akash, and I would now request you to kindly enlighten the house.
Thanks a lot, ma'am, for the introduction. And firstly, can you hear me, all of you?
Yes, absolutely.
Okay, and my screen is visible as well as I am also visible, right?
Yes, at the moment we can see you. You will have to reshare your screen.
Sure, sure. I'm just reconnecting him.
Sure, no issues. So, dear participants, I would say gear up your seatbelts because we are soon going to start with our session on cloud computing, how it is enabling the current digital transformations. Just a few more settings to be in place, and we will begin with our session.
Ma'am, I'm not able to share my screen. Any specific setting I have to do for this?
Actually, we will change the sharing rights. They are on your second device. So we have now given changed the sharing shares rights. Yes, now the screen is starting to share content. Yes, the PPT is visible. Absolutely.
Sure. Thanks, Ritika ma'am. Thanks, Huda sir, for the introduction. And first of all, I would like to thank Huda sir, ma'am, and the entire BVICM staff and faculty for providing me this platform and opportunity to share whatever little I know on cloud computing with all of you. And thanks for joining this session. So without much ado, I would just like to start off on cloud computing, and I would start off with the agenda of today's presentation. So I would like to go through the quickly on the background of the cloud computing. Huda sir already covered it, and the deployment models typically we see in cloud computing. Some of the observations of late that I have seen, I'll just go through them, and some typical jargon for a newbie who is just coming to cloud. It can be a little overwhelming, the terms that are thrown up: cloud native, app modernization, day zero, day one, greenfield, brownfield. So many jargons are there. Quickly navigate through them. And where do we exactly start, our journey? That is the sort of confusion amongst, people who are just coming to cloud as well as enterprises. So how this journey typically looks like. Uh, then what are the modernization strategies that companies are adopting to move over to cloud? Cloud has given a lot of flexibility to organization, but at the same time there are some concerns related to security as well as management. So that I will like to cover in the cloud governance and new streams of cloud which are opening up, multi-cloud strategy, FinOps, that will be covered toward the end. And lastly, I would like to focus a little bit on the role of cloud architect in the entire space. And we would wind up with, where we go from here, in our cloud journey. So that is the overall agenda. Quickly, I would just go through with my observations. So if you see, if you see, there were several reports basically which mentioned that lot of the companies, in that magic figure of 2020, they would basically be moving over to cloud by the year 2020. But that journey did not happen, the way, though we say that cloud is, the future, but the pace wasn't as much as it was anticipated. So what was the reason for that? Then during 2022, 1.3 trillion in enterprise IT spending will shift to cloud. But at the same time, if you see, just a minute. Yeah. But at the same time, you see the cloud, the companies are still, continue to invest in the traditional data center infrastructure along with the cloud services. And, by 2025, this expenditure in the traditional infrastructure will still continue to outpace cloud spending. So what again is the reason for that, that this is not cloud is still not outpacing the traditional infrastructure? Then there are issues of vendor lock-in, and how do you keep your business safe from these public cloud outages that we keep hearing, time and again. Sometime back it was Microsoft, then AWS. So is it really safe to move to cloud? There are concerns around that. Then another problem which is coming up is related to the workloads in cloud. uh, Basically, when you get teams onto cloud, they start creating then own workloads on the cloud. Then how do you ensure that how do you handle the misconfigurations, data breaches? How do you ensure that there are proper security policies in place really on your cloud? Then this is another observation. This is like one of the cloud spender. It was discovered that despite the 9 figures of a year of annual cloud spend, these figures are not being shared with the engineers. So there is a clear demarcation between your technical and non-technical staff. Basically the technical people would look into the technical side, and non-technical would be the people who would take decisions on the costing side, how the infrastructure and other decisions should be taken. So is it really a feasible strategy in cloud? Then lastly, there are overwhelming number of services, which are offered by cloud provider. And the real challenge for everybody, who is involved in the cloud is how do you keep pace with it? How do you learn, and how do you focus basically and pick up the stuff, that really you should be learning or where you see the future. So if you take a case of AWS Cloud Architect Associate, there are approximately more than 100 services that you really need to know, and that is just about AWS. We are not talking about other vendors such as Google Cloud or Azure. So these are the observations. And if you see the reasons for them, I would quickly navigate through them. The first one is basically related to the security and latency. Why that movement did not happen in 2020 is largely also because of the fact that companies are concerned about the security and latency, that every workload cannot be transferred to the cloud. So if there is some mission critical application where you cannot afford to have any sort of a latency, companies are very well okay keeping those kind of workloads still in their on premises. Then why this budget shift did not happen by 2020 when everybody was so upbeat about cloud? One of the reason is fear, which is also not born totally without a reason, because companies are really worried about this bubble cost that you give the platform to your developers, and then you start seeing the bills in the figures of triple zeros. So there are new programs such as FinOps, which is coming up to handle these kind of challenges. Then for vendor lock-in, we are seeing a lot of enterprises are moving over to multi-cloud strategy. They don't really want to go with a single vendor. They are opting for AWS, Google, both at the same time, and then taking a decision which would be the right platform to move their workloads to, or it could be a hybrid or a mix and match. Then Then for the workloads which are deployable outside and how do you ensure security, we have a whole cloud governance model which has come up. A lot of products are being released by different providers in that sphere. And second last, that how do you basically this, despite a 9 figure of a year spent, nobody was sharing the cost with engineers. So this cloud adoption cannot be done without being engineer centric. That is the core message, and we would take a look at that as well in the subsequent slide. And lastly, how to deal with this overwhelming number of services and how to ensure that you are learning and evolving. So for that, you just stay tuned. Maybe we'll pick up towards the end on this. So this is a typical, deployment models of cloud. I think in previous session also I saw that this was more or less covered. So generally there are four, public, private, hybrid, or a community cloud. So public is where, the likes of AWS, GCP, Azure uh, belong to. Basically, this is based on, consumption based subscription model, that as much as you use, you pay for it. And it is like, multi-tenant setup, or you can say it is more like a apartment where there would be one floor, and on the same floor there would be multiple houses, and other customers would also be given some space on in that environment with you. But there would be clear demarcations that your data and your security is not compromised when you share that platform or infrastructure with other clients. One of the main advantage is obviously flexibility, reliability, and cost that you see when you just move your workloads to a public cloud. Private cloud is more or less same as public cloud, the only difference being that the infrastructure is being used by a single organization. So if I have a company and I move to a private cloud, that whole cloud infrastructure would be available to me. So I don't really have to worry who my neighbors are, right? It is the whole entire floor belongs to me, or I have my own kind of a house which I have created. Sometimes people confuse that, private only means on premises, but that is not the case. It could be very well, it could not, it not necessarily it has to be on prem only. It could be on the similar to a public cloud as well. Benefits are, that it is flexible. You have entire setup, you are not sharing it with anybody, so those compliance and regulations are taken care of. One of the topmost consideration is obviously the cost. It is definitely going to cost you more, if you are going to build your own house. So the same analogy applies here as well. Then there is this hybrid cloud. Hybrid cloud is based on the concept of homogeneous. Homogeneous here means that, the cloud solution would belong to one stack only. It doesn't mean that I can combine Google with AWS. So I would be using, if I belong to Google space, I would be using Google only. But the advantage which it offers me is that I would be able to run certain workloads on-prem. So basically, if you take a case of Kubernetes, right? So you would probably have an advantage where you can run your runtime plane on-prem, as well as your management plane can be hosted on the Google Cloud. And basically, these two uh, planes would communicate, in an asynchronous manner. The advantage it offers is basically you would be able to get your compliance and regulations meet, because you are not really moving your critical data to the cloud. Then you have community cloud. These cloud, community cloud is specifically created where more than companies from the same domain, basically they come and they start to form a group, that we have the same requirements. So why not come together and, basically leverage that product which belongs to our community or to our domain. So sometimes a government community can come, and sometimes it could be, healthcare community, or companies can come together and collaboratively they can move to the cloud. So these are the basic deployment models. But the another typical model which has started to gain more popularity is the multi-cloud, wherein like it's a more like a heterogeneous, where multiple cloud providers like AWS, GCP, or Azure would come together, an organization would opt for more than one service provider. Yeah, any question you can just keep posting. I would take them up towards the end. When we talk of cloud, right, there are two terms which are commonly used. One is cloud native, and another one is cloud based. What is the difference in cloud native and cloud based? Cloud based is basically, when we talk of traditional applications, let's say a typical struts based application or a spring based application, which was created, in pre cloud days basically, or they would have a kind of a monolithic structure, running on Tomcat. So those kind of applications we normally are running on prem, but we like to move them to cloud. So if we move them to cloud, we call them, a cloud based application. But cloud native applications are basically which are created from the outset with the mentality, that they are going to be deployed on the cloud. So they would leverage typical features, such as microservices. They would have containers. They would be using DevOps pipeline, CI/CD. So all these concepts, would be natively built into such applications when you create or you design them. So in cloud native also there are two things. One is your greenfield, another is the brownfield application. So greenfield application means, that it is a development from the scratch, completely new, everything is new. So such applications are created for, this clan which we call as digital natives. People who are using mobile phones, they are going to get all the updates, probably very active on social media. So those sort of applications which do not carry any baggage of being a monolith or a past, and they are being built at a fresh for the cloud, that we call as a greenfield development or a greenfield application from scratch. Brownfield means that, company is ready to adopt to cloud, but there is still some workloads, which are legacy or they are old, but we want to probably, modernize them, and then we want to move them over to cloud. So it is not that we are completely starting from scratch. We already have some base which we cannot throw, but also it's going to be substantially larger. So we are looking for cloud, but we are looking to modernize and then move it over to cloud. So that is a difference between greenfield and a brownfield cloud native application. So then what exactly is application modernization? So if you see the definition, which appears to be pretty uh, long one, it basically addresses the migration issue of migration of legacy to new application or platforms, including the integration of new functionality to provide the latest functions to business. There are options such as re-platform, re-host, recode, re-architect, re-engineer, interoperability, retirement, that such modernization should address. So it's a bit technical. I would just try to simplify this definition for you. So sorry. So if you see a modernization, right? So basically, this is what this definition tries to tell us. If you see this, there is a three strategies which is it talks about. One is rehost, other is refactor, other is re-architect or rebuild. So basically this means that legacy workloads are already running. So if I try to move a legacy workload, let's say I have a Tomcat monolithic struts based application which I want to move over to cloud. So I just probably it is running in a Red Hat Linux, right? And I just want to create another VM on the cloud and just shift it, or lift and shift as is commonly called. So that is what we call as a rehost. You have just changed the host from your data center to cloud. The second category is refactor, where we apply some sort of rationalization. We say, why not use the platform as a service, or certain services which these cloud provider are providing. So for example, Amazon provides you Elastic Beanstalk, right? And there is App Engine in GCP. So you would say, why not transfer these workloads to these services and let Amazon take care of, the platform. We would just see that we get the results. We do not really have to worry about the networking and security of the VM. So those things would be taken care by Amazon in that case, and that we call as a refactor, where we are using, platform as a service and software as a service features of a cloud provider. The third category, which is the most dynamic out of the three, is a re-architect or a rebuild. So basically here we try to think totally in a cloud native way, right? We start to think about containers, serverless, infrastructure as a code, configuration as a code. So those sort of, Terraform scripts or creating pipelines through script. So those sort of cloud native capabilities we start to think, and we start to think that we should re-architect this application. So that is what we call as a re-architect or a rebuild. Generally, the point of contention is, so where do we exactly start? Because there are three strategies, but I have already application running. So most of the organization, they take the first route. They initially identify some workloads, that they think could be immediately shifted to cloud. So they might be having some legacy applications, right, that are mentioned. They would say, probably let's experiment and try to move them over to cloud and then see how this journey goes, get some experience, and then move on to the step number two. So this is what we call as a lift and shift or a rehost, right? Lifting your monolith apps and then transfer them from data center to cloud. Some of the advantages that it offers, obviously immediately you would see a reduced capital expenditure, because all your servers would be released, they would not be required. You have transferred your workload to cloud, which is substantially less expensive than running your own data center and machines. Then fewer resources are required, not only from the computing point of view but also from management point of view. You do not really want people to be managing your servers, and obviously fewer data centers to manage. So that is the immediate advantage, and that's the first point where these organizations undertake this journey. So these are the some examples from my experience that I have put here. So this one talks about rehost. So you basically we have an application which is running on a legacy monolithic web application, and we have transferred it to GCP Compute Engine that I just mentioned. So on the right side you can see that it is being deployed on Compute Engine now. So this is a rehost. Basically it was running on-prem, we have transferred it to GCP, right, Compute Engine. So now the VM which it is using is going to be GCP. Rest everything from functionality remains same. But one point important here is that it is not completely a rehost, right? If you see, this company is picked up, certain modernization capabilities as well on the path, of moving it. So they are using Terraform, they are using deployment manager, Jenkins as a CI process. So sometimes it's not that you would just pick up your workloads and just move them over to cloud. You also want to experiment some of the modernization capabilities also, along this journey. So this is a kind of a little bit of a mix and match, right, where they have done a rehost, but they have revamped some part of their infrastructure as well. They have revamped their operations as well a little bit, just to add that flavor, if I can say. So that is what we call as rehost. Now, the second one would be a re-platform. Re-platform means that we are not migrating it to Compute Engine, just picking up the app and just migrate, but we are also using some certain services which are being managed by the cloud provider themselves. So App Engine is a service, where you don't really have to bother about managing these VMs. Amazon has a similar technology which they call as Elastic Beanstalk, and Google calls it as App Engine. So they support various platforms like Java, Go, Python. So whatever application you are having, if there is the compatibility to the languages which these platform offer, you can transfer these workload to App Engine, where and let the cloud provider takes care of the management of the infrastructure for you. Rest of it, if you see, is pretty much same, right? You are still using your Jenkins pipeline. You have certain code quality, build, unit testing, Git features implemented. So from operations, it little bit is same to the previous one. Only difference being that now you are using App Engine as your platform choice. The third one is a refactor. What we call refactor is, that you have decided that you are going to use a App Engine Flex here, which means probably you want to containerize. Let's say you have a Java application, but probably you do not want to just run it under a JVM. You want to containerize it, and then you want to deploy and see, at least implement some sort of more modernization capability or do some sort of code changes in that. So that is the third category where we call it as a refactor. So basically, it is little bit same as re-platform with some minor changes, you can say. The fourth is the re-architect, right? Wherein we have moved these workloads. We have moved these workloads to Kubernetes engine, right? Or GKE in Google Cloud. So now basically it's a complete re-architect. This application was not built for running in Kubernetes, but you have re-architected and you have made it into a container kind of an application and deploying it on the Kubernetes. So one of the things or contention that comes out is your team should be able to take care of the whole GKE stack now because your application is deployed there, right? So the management of it, how the containers are run, those are some consideration which you have to take into account. Your team should be equipped to handle such sort of a migration. So that is a reason why we do not do it even as a first step, because the team is also evolving, they are learning new features. So that's why it's not advisable, and most of the times company takes small steps before they really come to re-architect. Once they gain some confidence, then they move over to this step. Sorry, just I have I think some sequence I have missed. This is about the how the modernization happens. So if you see a typical journey of enterprise customer who are looking to modernize or who come to us as a consultant that they want to move over to cloud, it involves a certain number of steps which you can see uh, in this slide. So at point number one, if you see enterprise decides, that they want to move over to cloud native platform. Probably some sales work has been done, some pitch has been shown to your client route, right? And now they are convinced and ready that they want to move over to cloud. So this is the step number one. Step number two is where we identify what are the use cases, for this modernization. So that is step number two. And generally, once this is done, then we move over to the assessment part, where basically we assess the client existing systems and requirements, because client also are new to cloud. So it's not that they knew that they know everything. So we generally advise that you go with a discovery and a assessment phase. So these phases actually which you are seeing here, right? If I say in a SDLC, we used to have a waterfall cycle, right? Where we will have a number of different phase starting from requirement gathering, then design. But this is more of a modernized, journey map for movement to cloud. Here, what we say is, day zero, day one, and day two. These terms day zero, day one, and day two are basically borrowed from military parlance, or as they do in military training, right? The idea of day zero is basically, what it matches somewhat to your software development design phase, where you basically gather the requirements, right? And then you do some designing. So that is day zero, that you actually identify exact requirement and do some designing on based on those requirement. If you have to do some proof of concept to validate whether this solution would work or not, what are the networking requirements, security, everything you would try to gather in your day zero. Then the second part, which is day one, right, is at where you would actually create or do the development. But the development will also not be that you pick up the design and you just start implementing. Before doing that, there is generally a concept of a minimum viable product, right, which we call MVP. So you would agree with your client what sort of features actually are important, or they would like to see initially, rather than going with everything at one go. So your client may say that we would like to see, A, B, C, D, E, F, but for us, A, B, C is probably, more important than D, E, F. So what could be considerations for this? It could be that they see more value in features ABC. Probably it is a login functionality of your site, right? Probably B is where you see the dashboard, and EF probably are some reporting features. So that is something that client probably is happy to see at the end. So those sort of definition of MVP is also done at your day zero, where you actually define what exactly needs to be done in day one and day two. One of the very critical step in this whole journey is your landing zone setup. What is landing zone now, right? uh, Landing zone is basically your initial foundation. So suppose you start your journey, right, or you bring a new mobile. We would come to this one, but basically it means you are setting up your networking, security, and other aspects, of on the cloud. That how would the different teams come, and start to create their own services. So all that sort of initial setup you are doing, which we call as a landing zone setup. Then MVP we already talked. Then day one is the actual development, right? So this step 6, 7, and 8, if you see of the diagram, where we are identifying the applications, we are doing DevSecOps, right? Setting up the pipelines and then evolving, right? So those are part of day one. And day two is when you have probably your go live has happened, or your product is now live, and you want to evolve now, right? You want to address certain new use cases. So that is what we call as day two of your journey. So that is what we are seeing in day two, where you are focusing your energies on monitoring, and optimizing the system. So that is day two. If you have any questions on the same, you just message, and then we will take it up in the towards the end. So I talked about landing zone setup and how the different teams will onboard onto the platform. But see, organization is a very big entity, right? So if I take a case of, let's say, HCL, so HCL will have so many different departments. It will have so many different teams. Each department might be having multiple teams. They might be running their own sort of projects, which could be in turn having different streams. One could be development, other could be testing, one could be related to production deployment. So how do we handle, when we have set up the platform and all these different teams, different departments, they are coming over and doing their own thing, that we still have security in place, we still ensure that the platform is not sacrifice or compromise in any way, in terms of security. How do we ensure that you are not taking any action on the platform which you are not which you are really not entitled to do so? So how do we ensure all these aspects? For a single person like me, just creating a Google cloud account and going over there and doing experiments, it's okay. But when you talk from an enterprise point of view, right, then there are a whole lot of governance aspects which have to be in place. So how the cloud providers are addressing this is that they have a concept of organization here. So organization, if you see in this chart, right, shows you the topmost entity. So if you see, it is company here basically, and then you have folders, then you have projects. Projects are your actual GCP projects, that you would create. I am giving an example of Google Cloud. I would move over to how it is in AWS. More or less it is little bit same, only the nomenclature is different, but that is how we are doing the governance on both the platforms, and even Azure is also more or less same. So if you see the third stage where we have projects, right, that is where we actually create our project, and then under the project we create our resources, basically app engine, compute engine, all those things, whatever we require to run our workloads, we would create over there. But this sort of a hierarchy actually gives me a lot of control, in a way that let's say I define a security rule at the top of my company that this should be the configuration of my compute workloads. Nobody should be able to create more than 128 GB of more than 128 GB of a compute server, let's say. I have set up that rule, right? So you would not be able to actually go and provision a compute resource which exceeds 128 GB. As well as I can even define the security that, let's say, what sort of actions you can take at the top of the hierarchy. So a department X is only able to access resources that belong to department X. They cannot go and touch anything which belongs to department Y. So these are the hierarchy that we have in a Google Cloud. So hierarchy or this organization structure gave us benefits such as you can do identity and access management, that who has what sort of an access. If you want to look at the hierarchy, you can basically go bottom up. Basically, if you have some resources, you want to see where do they belong, you just start with the resource and then you navigate up the tree. As I mentioned, you have centralized configuration, even auditing, right? You can basically see who is doing what in your platform. So suppose somebody from, let's say, from a marketing team of BVICAM is doing some actions. If he is not entitled to, let's say, do something which belongs to human resource, right? In the audit logs we can actually check that he is trying to go into a project which belongs to human resources, and he is trying to create something over there, and then we can take an action. So that is how basically one of the challenge which I talked initially, right, in my observation slide, that how do you ensure that maintain sanity on the platform and everybody is not doing whatever they want to do on the platform. So that is one way. If we see Google Cloud, and on the right side we have AWS here. So more or less basically they are same, right? If what I said, in Google we have a concept of organization node, here we have organization root, then we have folders, there we call them organization unit, and then like we have projects here which we call as accounts, and then we have the resources. So this whole hierarchy is more or less same. uh, AWS has certain products like control tower and all, which actually builds on top of this hierarchy basically, and then they implement more features. But this is more or less same. So if you want to explore it more, you can basically see those products, how they are enforcing the governance on the platform. Another important aspect is related to your billing, right? So if you see on the left side, we have shown it for the how the billing will happen. So basically there would be a payment profile which is associated with your billing account, and then for each of the team basically, so this is centralized profile which you associate. You can associate more than one payment profile also, but generally we have taken a one profile as an example. And then we can in fact bill different project teams. So suppose BVICAM has let's say a payment profile associated, and then they are probably charging, let's say, engineering institution as well as our management institution, because they are coming and let's say using the BVICAM on a cloud platform. So we can basically differentiate that sort of a billing for them. Amazon also have a what they call a service control policy that you can define at the top. So basically that is also same as what basically actions you can take on your resources. So yeah, that is the whole idea at a high level. I can go in depth, but actually probably in some other session we will take that up. Then the new streams which are coming up, right, that I mentioned. How do you manage cost in cloud? So there are two approach here. If you see on the left side, I have approach one, and on the right, I have approach two. Both are approaches to managing the cost on the cloud only. So in approach one, if you see, we have which application are costing the most money. On the right side, if we see, how do we use our resources more efficiently? Then we have, which components of the application cost most money. And on the right, we have how do we spend our money more efficiently. Then on the left, again, we are asking which infrastructure our money going to, which application team is, what sort of utilization they are having, why our bill so high. So if you see on the left side, we have a little bit of a negative tone, right? But on the right side, if you see, it's not a negative tone if you compare it, right? We are just talking how we can do things better than the way we are doing currently. Both are approaches to managing costs in the cloud, but they have a slightly different way of handling it, right? So that is what we call as a reactive approach, and the right one is a more proactive approach, where probably on the left side something has already happened, right? And we are just trying to put a blame on someone that, why this guy went up and he shooted our bill to, $1,000. Who created that VM? Why did we require really that VM to be running this long? So it has a slightly negative tone, right? On the right side, we are trying to ensure, that uh, basically, even if something happens, what was the exact reason, instead of putting a blame on someone, we are trying to proactively see that such kind of a action does not happen really, right? Or if such a action happens, then at least it is beneficial to the business, or it has a purpose attached to it, that we can basically map to. So if I created a VM which cost me $1,000, and let's say it was for a critical application, right, which could generate a revenue of uh, probably, some $1,000, more than $1,000 for that organization, then it is justified. I don't really have to put a blame on anyone. So that is what we call as a proactive approach. And building on top of it, we have actually, a framework which is now coming up, which we have begun to call as a FinOps. So some considerations, typically when you move to cloud is, on the left side, if you see, here are top pain points, which most of the executive have mentioned. Basically, they are saying getting engineers to take action on optimization. So they are talking that engineers are actually not taking the optimization action. Then 29% of forecasting, accurate forecasting of spend, 29%. So they are not able to forecast, what exactly are their spend going to be. 22% is actually, getting people to adopt FinOps, and 20% is, automation of the activities. Then 19% of a pain point is reducing the waste, or some resources are lying idle. They are running, without you really knowing, that they are up in the cloud. How do you align different teams? Finance thinks that, they are the guys who actually approve all the, invoices, and they are very misaligned from your engineering work, right? So how do you get everybody together? 13% is for the full allocation of cloud spending. So all of them are actually, related to costing. And if you see on the right side, uh, if you see on the right side, we have involving engineering team during aggregate cost review is not going to work. It requires cultural shift. Basically what happens, engineering team or the technical people, they are brought in, in any organization once you have received a bill, right, or that cost has already occurred. But companies are little wary of that. They know that this is not, how cloud works. Cloud is actually where you actually create some resources, and you are real time, doing something, and it should be possible that at that point itself you should know what is the actual bill that's going to be. Feedback loop of real-time reporting is a powerful influence. Why not engineers with feedback on the impacts of their action on cloud as close as possible to the time those actions occur? So basically what they are saying is that why not give them a feedback loop, right? So suppose you are driving an electric car, right? So in electric car, when you press, you get a real-time feedback, basically, how much energy you are consuming when you put a pedal on your accelerator, which is different from, your petrol or a diesel car. So that sort of a feedback loop, why not to incorporate in a cloud? Suppose you are creating a workload. If I tell you this is what it's going to be, right, as an engineer, you would basically be wary of that, and you would take some sort of a second thought before you really create that workload or you start a new VM. And is it all about going to be about saving money, cloud and cost? Or we should think beyond that also, right? There is this consideration. And the next point is that a government agency will have a very different budgeting and forecasting process than a private company or a startup. So how do we standardize, all these points and all these pain points and handle them, because there are quite a few actually. So to handle all of it is basically a new stream is coming up, which we call as a FinOps. It's a relatively new stream. Initially, if you see AWS, right? They call it cloud financial management. So if you have a friend in AWS, he would be calling it cloud financial management, but it is same as FinOps only. Some people old names are cloud cost management, cost optimization. So those are some other names, but the recent name which has come up is FinOps. The reason why it is called FinOps is that it echoes, with DevOps. Basically, DevOps is your development and operations combined. So now they have given a new direction to that, which they call as a finance aspect to this entire operations, right? So which is gaining popularity. If you see on the left bottom side, right, the FinOps skilled resources by in 2019 it was almost zero, but now in 2022 it has reached to 12,500, right? So you could see that how much of a demand curve this new stream is uh, generating, in the cloud. So everybody is talking about FinOps. If you see from financial to manufacturing, now every organization is keen to create a FinOps practice. Core values which emerge in a FinOps is, that teams need to collaborate. They should work together, and decisions of cost are not, that you put cut a cost. Basically, they should be driven by a business value, that how much of a value that cost would generate for your business, and if it is justified and okay, then you can go with it. You decentralize decision making, so give engineers the powers that they can actually take or create, workloads, but they should be aware of their actions actually. So each of the team should be powered, and this agile practices that each team is really powered, that should be also from the finance perspective, not only from other metrics. Make the reports available to them, monitor real-time forecasting and planning, which I talked about earlier, and then have some sort of a benchmarking, for internal teams, that how they are really faring in terms of FinOps, whether they are improving or they are at the same stage. Because right now, if you talk about cloud, before the FinOps, there was no really way to gain, to gauge basically uh, how internal teams are doing on the finance perspective or finance side of things. Generally, they have a centralized teams, which they call as a FinOps COE, and this team would evangelize and sensitize people about financial management or FinOps. So that is a model which most of the organizations are adopting, and rate commitment discount optimization are centralized. So basically, suppose you have two teams, right? One works in a morning shift, other works in an evening shift. So there is really no point of creating the servers for one team which are going to be idle in the night, right? So when you see from a centralized point of view, you could do all these optimization if you're running a FinOps COE, because they would know which team is operating in which hours and what sort of a compute capacity we have. So if it is not available, a team is not available in the night, same capacity could be leveraged by other team, because everything is centralized. So that those sort of decisions you can take, and you can really bring more value to the business. This is the roadmap, and there is a framework for FinOps which is created. I would not go into the depth of this, but basically these points are already talked about, right? You plan, you socialize, you prepare for this journey, and then you launch it basically, and get everybody on track, in this FinOps journey. So it should not be that engineers are not about aware about the FinOps. Basically, you involve them in the whole journey, and I would share the link of the FinOps site where they have this framework also defined. So this is what is the recommendation from the FinOps Foundation basically. So they have these roles or persona which they have identified. There should be a practitioner, executive, owner. So little bit same as if you see from agile point of view, it is also a kind of framework which probably, organization who want to embrace cloud and are also looking to, create a FinOps kind of a practice they would like to go through. There are three phases here which they have mentioned, uh, you know, uh, which basically define their maturity cycle: crawl, walk, and run. So that is the model. You can find more information if you go to their site. I would share the link separately. So this is a sample report, if you see, right, which I just put it for understanding. If you see, let's say a company has started embracing FinOps and they send this report to you, where they have put certain service cost of team A and they have certain cost of the overall cost, for application or the most costly applications. They created this, and let's say they send it out. They said, we have adopted FinOps and this is your report. So what do you make out of this report, right? Is it appealing to you, or does it sound, positive, or that it is probably right for you? That's, it covers everything. So let's just quickly go through this report. What could be better in this report? So if you see, we have the most expensive services which they have mentioned at the top, right? Which basically, if I am an engineer, let's say, who belong to team A, I would immediately compare my application 5 with probably application 1, 2, 3, 4, right? And I would say I have only 2000 for 5, 6 is also less, 7 is less, 8 is also less. So I am probably, very much covered. My services are not really that expensive. But is that the right sort of a judgment for me? Or firstly, like, whether I should be, given this information about the top services this week or the weekly cost of them? So if you see, presenting the cost of this service alone without spending of other team will help avoid the bias and allow your team to assess the cost of this service more fairly. So if you do not tell me, which are the top expensive services, or if you just give me my data, then probably, I would not really compare, how the other services are doing. That is what it's trying to say. Then the last point is that the reason why they included extra information is probably they want to be more informative, right? They want to tell you what is happening in the organization. But then probably, there could be other ways to share that information. So probably this could be better. It's not really, that this report is the ideal one. Probably there could be parameters such as, what sort of a value it generated, or what was the impact on the revenue for these applications. So those sort of information is really not available to us, right? Let's say there is another team who is doing similar kind of work which team A is doing, right? Then probably some insight into, how much it is costing to them, that could be probably more beneficial. So that is how actually, everybody is evolving. So there is no right or wrong. Everybody will learn over a time, that probably this report is not, that much conducive as terms of results. They would probably go for a different format next time. So I talked about this observation, right, that companies are really worried about this whole cost bubble. So this is a real time data, right? The company actually adopted a FinOps model. They involved the engineering team, into FinOps discussion, and immediately, like, they were able to reduce their, if you see, their spend, right, by dollar. Almost like 200K, right? Which they were just spending unnecessary just by discussing it with their engineering team, right? And it took them just 3 hours of activity. They just shut down all the unnecessary resources, in their development environment, and that much of a saving they could just immediately do. So that is this is what you can see, right? How much of an impact it has, just by involving your engineers. And the lesson, if you see on the right bottom, right, trust your engineers and turn your FinOps process into another efficiency metrics, because engineers are averse to inefficiencies, right? So if I am an engineer, I know that, this is something I should be cognizant of. Then obviously I would treat extra, expenditure as an inefficiency, and I would be aware and, take it into consideration. These are the emerging fields, right, that I talked about earlier. This is basically where the organization are heading. Basically, this is a multi-cloud setup, if you see, right? Sorry. So if I talk about at the end of the 90s, right, none of the organization considered IT as their core activity. Basically, the idea was that we would outsource it to some other company and they would be the one who would be managing. But that whole ideology has changed now. Every company now is a software company, and people like Satya Nadella and other, top executives of IT are also, vouching for that fact that if you take the, for example, the case of banks, right? A bank used to be probably a company which will outsource, but most of the banks are now a typical IT company. They are running a lot of data streams, doing data analytics in-house. They have own applications, and they are even developing applications for their clients. So that is how, the IT, uh, non-IT companies are also moving over to technology. And this is how the future of IT is going to look like. If you see, right, this is really a multi-cloud model where companies are, looking to leverage the best of the provider for their workload. So suppose if you see, if you take, it is also hybrid as well as multi-cloud. So I am using AWS, Microsoft Azure, Google on the public cloud side, and on the private side, if you see, I have, AWS Outpost, which is like you can run your workloads on prem only. Then Microsoft Azure has Stack. Google has released Anthos, right, for running your containerized platform. And then you have OpenStack on prem. So it is basically all going to be, mix and match. Like I would probably take a workload and see, as I mentioned, right, using my FinOps model, that how much it is going to cost me, on, let's say I take it to public cloud. Then I would compare over there, Google is probably costing me this much, and probably AWS is costing me this much, which is probably less, so probably I would move it over there. There could be other parameters such as security and all, that I would measure. So probably if it is some kind of a compliance workload, I would stay on the private side of things. So that is how it is going to look like. Some challenges which are not very explicit in this diagram, if you are going to have a multi-cloud setup, how are you going to connect, two different clouds together? How would the networking look like? How would the governance in a multi-cloud model would look like? We talk about governance for a single cloud provider, right? But if there are two, three different cloud providers and my teams are onboarded onto different platforms, then how would it all integrate together? So those are some challenges which companies have to address, and probably we'll save it for some other day and discussion. I would just talk quickly of hybrid solution. Hybrid solution basically focus, on bringing, basically the initial idea was take your workloads to cloud, right? But hybrid changed that. The hybrid model says that why not bring data to the cloud rather than, taking your data through the cloud, because your compliance team would and security team would be highly they would disapprove, of such kind of a transfer. So that is why we are opting for a hybrid workload. I talked about lending zone, right? And I talked it is little bit similar to your uh, mobile. So suppose you got a new mobile phone, right? Then how would you, start this phone, or how would you make it operational? You would basically take it out of the box, switch it on, get a subscription from a telecom provider. Firstly, you would charge it, then you make sure it is connected right with some Wi-Fi device, and then you would have some apps, install, which you would download from the app store, depending on what sort of a OS it is having. It could be Android, it could be iOS. It could be you would set your language settings, you would configure your preferences, your personal details you would enter in there, your email account and everything you would configure, right? And lastly, like, you would basically make sure that your data is also synced to your cloud, if it is being offered by your mobile phone. So all this is basically, kind of, you are creating a lending platform for your mobile phone, right? Which is also similar to your cloud also. So people who are moving to cloud, for them also it is little bit similar. They have to actually create a lending zone, for their teams, where they could come and they could deploy the workload. So it is the analogy, basically, if you want to compare what exactly is a lending zone, it is similar to your mobile phone, where you are configuring security, networking, your data, everything on the cloud. So our teams which are coming over, they don't have to worry about these cross-cutting concerns. I talked about this journey, right? But let's see this journey from the eyes of a cloud architect, right? So if I talk about cloud architect, where exactly cloud architect would come into the in this whole journey. So they would be basically starting up their work. If you see on the right side, uh, from the assessment, they would be involved. Even like when you are pitching, your enterprise decides to establish cloud platform, they would be in touch with your customer during those discussions. And then when you lay out the foundation, that is where your platform teams would be involved. And cloud, this architect is basically, if you see all the critical aspects like, development. So this pilot project is something where the development is happening, right? Cloud architect would be working alongside the developer, guiding him, on what basically he envisaged about this whole system. Then, like in the DevOps side, if you see, there is a DevOps engineer, but then there would be an architect to guide him, right? What is the strategy which he thought about, creating the pipelines? How is your uh, Git branching strategy going to look like? So he will not be the one who would actually implement, right? But he would be the one who would be guiding, this team across the all the phases. So this is how a typical structure of a team looks like, right? It's not a fixated, but it is more or less, 60-70% it would be like this only. There would be a development guy, there would be architect, there would be a salesperson, a platform and infra team, and if for some project there are need for a database admin, they would be there. And there would be some experts, right? Or you can say from client side, certain app owners, they could be domain experts who would actually participate in this whole cycle of creating or modernizing your cloud platform. So what are basically the roles and responsibility of a cloud architect, right? So there are a lot of responsibilities and uh, if you see, and in terms of this role, basically he's the one who is going to provide you the vision and leadership to the technical team. He should know how to manage the stakeholders concern. He would participate in the requirement gathering, help your teams to choose the tool. He would be the one who would design the architect. They create certain run books for your team. They are the people like, who would communicate in the language of technology as well as, on the non-technical side as well, what language that business understands. They would mentor the team members. They would understand different design patterns, that I've not covered the design patterns because, that is probably we'll cover in some other session. But there are a lot of cloud native design principles and patterns which they should be aware about, right? Especially when you're creating microservices or a data driven architecture. uh, then the verbal and written communication, they should be the people who should keep learning, and they should be always, have a mindset that they want to evolve. They understand not only technical, non-functional as well. They would create certain run books for, their practice. So for example, in my practice, we take this ownership, all the architects, that we create certain playbooks, run books for our team. So if you are coming, as a new architect in some project, you are not starting from scratch. You already have some kind of a landing zone in terms of your architect journey. And lastly, like, which I have just put from my experience, is sharing, right? They should be able to willing to share what they know with others, because a lot of time what I have seen, people they know but they are not willing to share with others, right? There is some sort of a uh, um, scare that they have, if we share it with others, they would also know about this thing. So that should not be the case. As much as you can share and get other people also in your journey, so that should be the mindset. And with that, I actually come to end of this presentation. And then the last one, I have just put a message actually, which was there in our BVIChem website, that we created a long way back in 2005. So only as high as I reach can I grow, only as far as I seek can I go, only as deep as I look can I see, only as much as I dream can I be. So that is a message, for which I found is very valid for a architect. So with that, I come to an end of this presentation, and I would be happy to take any questions from you.
Thank you, Akash. Thank you for the wonderfully enlightening presentation. And there are a number of questions that we have today. So I will now take them up with your permission.
Sure, ma'am.
Okay, fine. The first question we have, if there are concerns about transferring critical data to the cloud, how is the bubble cost handled? And is it not a deterrent in the success of the cloud?
Uh, Yeah, it is a deterrent, but as I mentioned, right, that there are different strategies to cloud. Basically, so you basically the phase which I mentioned, there is an assessment phase, right, or a discovery phase. So the idea of this phase is you try to remove these roadblocks, right? So if there is some security or a concern that you have, in terms of a certain workload which you feel probably will not be meet on the cloud, you would basically raise it upfront. And then sometimes actually it so happens that, let's say, a service provider or a company like HCL, right, they are actually using Google Cloud, right? They would probably have that discussion with their experts as well, that our client is willing to come concern, will it be made by your public cloud platform? So they may say, that probably public cloud is not the right use case or a right choice for that. They probably should go for something like a hybrid, or they probably would suggest some other strategy to handle. So it is all depending on your use case. You have to take that call. And as I mentioned, that is why this multi-cloud model is coming up, right? Because of the fact that not all the use cases can be catered by a public cloud. It is good for exploration and learning, but not for all the use cases. So yeah, I
Thank
hope it answered. Yeah.
Absolutely. Next question we have. What would be the reskilling or upskilling challenges in cloud adoption by a conventional organization?
It is a cause of concern in a way that, how do you actually, as I mentioned also, right, that there are around more than 100 services if you prepare for AWS certification itself for a solution architect associate. So it is a challenge for them, but obviously there are a lot of programs which are, happening in house also, in various organizations to reskill and upskill the people. And also you should be willing to actually unlearn also, a lot of things when you move to cloud. Because like the thing is, you are still having that sort of a mindset, right, that you created something. A lot of time, like I see people, they created something on the cloud, but they don't really know what is the security mechanism, whether it is really safe to put that data. So yeah, so somewhat I feel that you should also be taking a lot of initiatives from your side as well, right? uh, Not just organization, but from your side also. And also you should be able to pinpoint, what is exactly your area of interest, rather than going with the trend. So if it is, sometimes back, it was DevOps, which was in trend. So a lot of people actually, which probably they didn't really have the aptitude, or they were not suited also for DevOps, but they ushered into that line because other people were also going in that direction. Then it was AIML. So it's not that we should not follow the trend, but also we should be considerate of our aptitude and, our experience, and what really, we are more comfortable with, because there are a lot of options, but we have to pick up the right one.
Absolutely, very rightly said. Next question we have. Please throw some light on how load balancing differs in single cloud and multi-cloud environment.
For a single cloud, if you see, there are different load balancers which are available. So in all the, like if you compare it with the OSI model, like the different layer 7 would be a HTTP load balancer. For layer 4, there would be a network load balancer. So there are different load balancers which are available, and depending on, how do you want to balance your workload. So if you have a Kubernetes workloads, basically you could also associate a mix, which are like auto scaling group of nodes, you can say, which automatically based on the load, they would kind of scale up, scale down, whatever you said. So that is how it is happening in the cloud. In case of a multi-cloud, as I mentioned, right, so multi-cloud, ideally, if you firstly you have to first of all decide whether you want to run this workload in a specific let's say you want to run it on Azure, right? And whether you want to run it on Google Cloud. Now, what you are trying to, I think, ask is basically these two want to communicate together, right? Let's say some of it is working in Azure, some of it in Google Cloud. So basically, then it is not about load balancer. It is about like how do you set up this kind of a networking between a multi-cloud, which is basically again a kind of a network specialist who would do it. So a cloud architect also has multiple dimension. Some of them could be probably somebody like me, right, who is more on the application side, but there could be a cloud architect who is well versed on the networking side. So I know about networking, but that is not my core area, right? But the person who is basically on the network side, he would be the one who would address such challenges. So as I mentioned, that you really have to pick up which category you belong to. It's good for your learning, but then actually there should be one area which you are really strong in, and then yeah, so that is somewhat a networking related issue what you are trying to ask, load balancing
Absolutely.
in a multi-cloud.
Absolutely. Next question we have. For any given problem, how do we determine which cloud platform to select, like GCP, AWS, Azure, IBM? How do we make this decision?
Yes, it's a good question. So firstly, there are two scenarios. One is you just want to opt for one cloud only, right? That is how generally organizations start initially. At least if they are moving, they would not go with multi-cloud from a very outset. So the basic considerations over there, at that point, is which sort of services are they going to consume more. Let's say they are going to use a gateway, for example, right? So Google has a APG gateway, which is the number one gateway, out of all the choices. So if it is going to be initially gateway, right, which is their topmost priority, they would obviously see how much that gateway is costing them, right? And what are going to be then the cost of the workloads which we are going to deploy. So in that sense, they would actually take that decision, that how much is going to be the total cost of ownership, as we call it, right? When they move to Google, and let's say I move to AWS, then what is going to be the total cost of an ownership in that sense, how much the licenses would cost, whether that platform, Kubernetes is, for example, by Google, right? So probably Google has an edge if I am going to run my containerized workloads, because they are the pioneer in that actually area, right? So all those are kind of decisions which we have to take. I probably didn't talked about it, but yeah, I think that is one of the very important consideration, being an architect of decision making actually, because a lot of
Absolutely.
time what we should go with A or B, and your client is also asking you only, those sort of questions. So that is where these frameworks are being developed that I talked about, FinOps one, right? So yeah, you can
Great.
take that call using those frameworks.
Okay, thank you. Next question. How strategic confidential government department can migrate their operations to the cloud? And what kind of security mechanism will be adopted to maintain confidentiality? What will happen in case a war strikes and when your cloud services are hosted from an enemy country?
That is a very, I think he must be following this Ukraine and Russia war, but yeah, but it's a valid question actually. So that is where, because I mentioned if there are very critical workloads, right, and there is this community cloud also. So for such kind of workloads where you feel, that it's not, you can't really go to public cloud, right, with all sort of a workload, you would probably create some kind of an on-prem or a private cloud in those scenarios. Maybe that would be probably you need to take into consideration, because it's going to be very critical. So you would like to keep those workload in a safe and a private space.
Absolutely. Next question we have, if a single person belongs to multiple departments, say logistics, HR, etc., how secure shall be the cloud?
So that's what I talked about, governance, right? That how do you ensure one project cannot access the workloads of other project. And let's say some projects can access, right? There could be, for example, admin department, who probably can see some of it from HR, from marketing. So all that policies we have to actually create. There are various tools for that, IAM and cloud tower service control policy. So there are various tools which these cloud providers are offering, you know, to really control what sort of access we can enforce on the cloud.
Absolutely. Next question we have, how could we scale up on demand the running instances in cloud?
So there is a concept of managed instance group that I mentioned, right? Which is, and then you can associate them with your load balancer. Somebody asked, and then based on you know, you have CPU utilization and other metrics. So there are a lot of metrics actually which are captured on the cloud. So there is monitoring and logging which is also there. I didn't talk about that today, but basically based on those metrics, you would create some kind of a rule or a policy, right? That you probably, if it reaches 70%, you want to scale up. If it is probably CPU utilization is below 40%, you want to scale down. So those sort of policies you can set up and scale up or down.
Absolutely. How should a beginner start with the cloud from the very scratch?
Yeah, it's a good question. So basically, there are a lot of initial certifications that you can do, right? For a beginner, basically. Even like, I think there are some beginner certifications which are there in all, like AWS as well as Google Cloud. So and like 3 months, you know, Google Cloud gives you a free uh, account, right? You can create your account, do some experiment. AWS also offers you a lot of free features, right? I think you can create for 1 year, earlier it was. So in that, you can create your account there and prepare for, you know, this certification, initial foundation level certifications, like how do you create a VM, and also side by side just read a bit more, you know, on these cloud native principles which I talked about. Somebody is asking how do we scale up, right? But firstly, like, why should you scale up? You know, what would be the need for scaling up? What are the factors? What sort of application need to scale up? So there are a lot of design principles are also there, which I cannot cover actually in today's session because of time. But those cloud native principles, and start with the initial level certifications when you want to move over to cloud.
Absolutely, Akash. Thank you so much for this wonderful session. I think we'll require another session to handle all the questions because there are a number of questions on load balancing, security, etc. But
Yeah, you can mail me. I think if there are any further doubts, I would share my email ID.
absolutely. So, with this, we come to an end to this wonderfully knowledgeable session today. I would now request Professor M.N. Huda sir to kindly present a certificate to Mr. Akash Sharma as a token of our remembrance for this wonderful session today.
Thank you so much, Akash.
Thank you,
Has
sir.
been a very lovely session, full of information. I personally believe that cloud is such an evolving topic, and the way it is penetrating almost in every segment of our technology and technological life, that it needs many more sessions.
Yes,
And
sir.